On This Week in Enterprise Tech, Europe is falling under ransomware, Microsoft is building something special, and Kingston just changed what enterprise SSDs can do for you. Quiet on the set.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for This Week in Enterprise Tech is provided by CacheFly at CACHEFLY.com.
This is Twiet, This Week in Enterprise Tech, episode 239, recorded May 12, 2017. Kingston SSDs build and European ransomware. This Week in Enterprise Tech is brought to you by Cloudflare. More than 6 million websites, apps, APIs, and SaaS companies use Cloudflare's services to weather whatever the internet throws at them. For a free online chat session with a Cloudflare support engineer, visit cloudflare.com/twit. And by GoCD, an on-premise open-source continuous delivery server by ThoughtWorks. GoCD gives you complete control of and visibility into your deployments across multiple teams. Since GoCD is open source, you can download and use it for free. To discover the power of their pipelines, visit gocd.io/twit. Welcome to Twiet. This Week in Enterprise Tech, it's the show dedicated to the enterprise professionals, the IT pros, and the geeks who just want to know how the world is connected. I'm your host, Father Robert Ballecer, the digital Jesuit, your guide to all things in the enterprise. But you know what? The enterprise world is awfully big. I'm going to need a little help from my friends, starting with Mr. Lou Maresca. He is a senior engineer at Microsoft. Lou, I'm just going to say there's been some interesting things happening on your campus the last week.
It's like a tornado. I mean, there's just spinning around. The things are going around my head. Yeah, tons of stuff this week with Build 2017. So really cool stuff coming out.
Yeah, we're going to be talking a little bit about that in a bit. But before we do that, let's go ahead and say hello to the other permanent tech head here at Twiet, and that is, of course, Mr. Curtis Franklin from Light Reading. Curtis, good to see you, my friend. How have you been?
Padre, I'm doing well. It's been a busy day here on the East Coast. Been following a huge story, and fortunately, I get to talk about it with the Twiet Riot in just a few minutes.
Well, gentlemen, we're going to be getting to that all coming up soon. And of course, we've got some special guests. If you've ever wondered about the future of SSDs, about flash memory, about really fast storage in the enterprise, you're going to want to stay tapped because we've got friends from Kingston who are going to be showing you their new secret sauce. But first, we got to jump into the blips. Now, this past Monday, Comcast and Charter, two of the largest cable ISPs in the United States, made a joint announcement that they would, quote, explore potential opportunities for operational cooperation in their respective wireless businesses to accelerate and enhance each company's ability to participate in the national wireless marketplace, unquote. In non-PR speak, Comcast and Charter have separately contracted with Verizon to resell mobile service through the Verizon network, most likely with some unified communications functionality built in to leverage their own networks. That much is great. However, when you unwind the language of the release, you find that the two regional cable operators have just agreed to not compete against each other as both companies get into the mobile virtual network operator business, or MVNO. Specifically, they have agreed not to make mergers with other mobile carriers without the express permission of the other. Pundits were quick to point out that this seems to be a textbook case of anti-competitive behavior, but both Comcast and Charter are arguing that since they don't already compete in the wireless realm, anti-competition regulations don't apply. Even so, this is probably not what the FCC had in mind when they suggested that the ISPs could regulate themselves. Or, more troublingly, it is.
All of you know about the repeal of the FCC broadband privacy rules recently, which boosted requirements around transparency of data and security practices, which include making customers' browser history as proprietary and personal data requiring permissions before using that data. Well, Seattle, Washington wasn't too happy with this repeal and acted quickly to reconcile the issue. Part of the city's municipal code already called out for rules around privacy standards for subscribers of cable service and other services provided over the cable system. In order to reconcile the repeal, the city Council immediately added requirements that cable internet providers obtain opt-in consent before using web browser history or other internet usage data for its own purposes. In addition to getting opt-ins from consumers, ISPs would have to provide their privacy statement to the city authorities for inspection yearly, and if they do any aggregating and anonymizing of data, provide their methods and reasons for doing so. The rule affects some of the larger companies in the area, Comcast, CenturyLink, and ISP Wave. Unfortunately, companies that do wireless internet are not yet bound by this new code. May 24th is marked as the deadline for the new rules. If you're in Seattle, look out for a nice big fat update in your privacy standards from your ISP coming soon.
Do androids dream of electric experts? The Environmental Protection Agency, or EPA, will not be renewing the terms of at least 5 scientists on its 18-member board of scientific counselors, according to a Sunday night report from the New York Times. The Times wrote that EPA Administrator Scott Pruitt would consider replacing those scientists with representatives from industries whose pollution the agency is supposed to regulate, according to J.P. Frere, a spokesman for Pruitt. Now, although all the scientists being dismissed are at the ends of their 3-year terms, appointees to the board are generally not seen as political actors and usually have their terms renewed. In addition, the appointees were apparently told in January, and again by EPA staffers more recently, that they would have those terms renewed. This sounds an awful lot like the world of Blade Runner, where industry rules the world and pollution has run rampant. Now, my question is whether this marks the end of the scientific process on regulating industry, where profits overrule peer review and scientific inquiry on EPA policy.
Remember that remote admin hijacking flaw in Intel chips that has been there for about 7 years? Well, it's worse than we actually thought. This flaw allows hackers and admin access control to massive clusters and rings of computers without actually entering a password. A report published recently says that the vulnerability, which is part of AMT, or the active management technology, which actually allows access to change boot code, accessing the PC's mouse, keyboard, and monitor, and as well as loading programs on boot. AMT is available on Intel vPro CPUs, but normally it requires a password when it's protected. Well, this exploit can bypass that password with no text at all. The cryptographic hash used to verify the password will still work even if you don't even enter text. Access to AMT are not typically logged or audited on a PC, so this is a pretty bad exploit. Intel's response was that PC makers will be releasing a patch in the coming weeks to plug the hole. So keep an eye out for that patch, or your PC will be pwned with the best password in the world. Nothing.
We'll keep the happy news about malware going with the news that Microsoft has quickly patched malware protection engine vulnerability. Now, a critical security flaw in the code for Microsoft's malware protection engine was repaired by the company within 2 days after it was first reported by 2 researchers. This helped lock down the code to prevent malicious attacks against users. In a May 8 security advisory, Microsoft acknowledged the update for its malware protection engine, which addresses a vulnerability that could allow remote code execution if the Microsoft malware protection engine scans a specially crafted file, which would lead to memory corruption. An attacker who successfully exploited this vulnerability could execute arbitrary code in the security context of a local system account and take control of the system, the company reported. An attacker could then install programs, view, change, or delete data, or create new accounts with full user rights. To the Microsoft Bug Reporting Program, a very heartfelt thank you.
You know, a funny thing happened on the way to the FCC rollback of the net neutrality regulations. It seemed that the same American majority who fought to establish the net neutrality regulations in the first place are still interested in net neutrality, and also bot alert. John Oliver, whose talk show plea during the first net neutrality debate generated such an influx of angry citizens on the FCC comment page that it crashed the site, seemed to do it again. This time, however, the FCC released a statement that the downtime was not because of a rush of concerned citizens, but because of several DDoS attacks that just happened to coincide with John Oliver's challenge in the second net neutrality debate. The FCC statement, almost devoid of details, has baffled Democratic Senators Ron Wyden and Brian Schatz enough that they are demanding that the FCC show the logs that they used to conclude that this was in fact a DDoS attack. The underlying concern is that this seems to be completely in line with the new deflect and deride strategy for dealing with concerned citizens that has taken over D.C. FCC watchdog Fight for the Future suggests two possibilities. One, the FCC is intentionally mislabeling the traffic as an attack in order to claim in the future that Americans were actually not concerned about net neutrality regulations. Or two, there actually were DDoS attacks perpetrated by individuals or organizations that are invested in keeping American citizens from voicing their opinions. Oh, and as for the bots, at least 83,000 of the now more than 800,000 comments appear to be the same comment posted by a bot network asking the FCC to change the regulations. This is getting dirty. No matter which way you lean, you should take the opportunity to voice your comment by going to www.gofccyourself.com. That does it for the blips. Next up, we're going to be jumping into the bites. We're going to have to talk about a little ransomware attack over the pond, as well as what's happening at Microsoft Build. But first, let's take a moment to thank a sponsor of This Week in Enterprise Tech. Now, this episode is brought to you by Cloudflare. You know Cloudflare. They're the ones who specialize in stopping DDoS attacks. They stopped a 400 gigabit per second DDoS attack back before anyone knew you could be hit by a 400 gigabit per second DDoS attack. They're the ones on a mission to build a better, safer, more reliable internet so that you can stop worrying about downtime, slow load times, or ultra-complex management. Now, Cloudflare has a global network of more than 100 data centers that caches your content and moves it closer to your visitors. They speed up every request to your site with performant DNS, caching, content optimization, load balancing, and more. And even with all of that and all of those features, you can be up and running in less than 5 minutes. That means you can make your site, app, or API more secure in less time than it takes for you to go down to the corner for a cup of coffee. Now, I know that they earned their rep by mitigating DDoS attacks, but that's just the tip of the Cloudflare iceberg. Their web application firewall, or WAF, is powered by a massive IP reputation feature. Their security team is constantly watching for fresh 0 days and deploying firewall rules to block exploit attempts proactively before they get to you, before you have to report them. They also offer flat pricing for everyone. Now, with this kind of protection, you might expect to get a massive bill every time you get attacked. I mean, that's typically how it works. But Cloudflare offers flat pricing. If you're hit by a DDoS or a surge in legitimate traffic, you pay the same amount. The plans range from free, that's right, free, to $20 a month to $200 a month, and custom plans for the enterprise. Now, Cloudflare is offering Twit listeners a free online chat session with one of their top support engineers to answer any of your questions. Just visit cloudflare.com/twit. That's cloudflare.com/twit to sign up today. Once again, cloudflare.com/twit. And we thank Cloudflare for their support of This Week in Enterprise Tech. Gentlemen, I'm going to ask Curtis to take the lead on this one because it's just happening today and it's pretty bad. Here's what we know. We know that in the UK, a massive ransomware attack has hit more than 70,000 systems, including some very vital emergency health systems. Curtis, can you tell me a little bit about Eternal Blue?
Well, Eternal Blue is a vulnerability that was first reported to the public as part of the Shadow Broker's NSA data dump back in April. So this is really one of the early instances of one of the NSA hacking tools being used as part of a massive, massive malware attack. Now, as Padre mentioned, we've had reports of well over 70,000 systems being attacked globally. Now, the bulk of the systems attacked so far are in Russia, with both Europe and Asia also seeing some fairly heavy hits. Africa, at last report, is starting to see systems being hit. And yes, there are some systems in North America, although at this point, we lag far behind the rest of the world in total number of systems being hit. Now, the thing that's really gotten everyone's attention here is not the sheer number of systems being attacked, although that's pretty impressive. It's which systems are being attacked. In the UK, one of the major victims is the National Health Service. And at last report, over 16 different local operations, think of these as hospitals with their associated doctors' offices and clinics, have been hit. And in many of those, because of standard protocol, when something like ransomware hits, systems have been shut down, and that includes things like the systems that monitor patient care, that monitor critical conditions for patients. And so we're already hearing some fairly heart-wrenching stories of everything from surgery that's deemed elective being pushed off, all the way to things like emergency cases being routed to different hospitals, and even nurses and doctors sticking their heads out of doors and shouting down the halls when patients are going into critical situations because the systems that normally monitor their conditions just are offline now. In addition, things like Spain's national telephone system, Telefonica, has been hit, and many of their systems are offline. Now, it's important to look, I think, at what's being hit with this vulnerability. And the fact is that what was being hit is the Microsoft server message block, specifically server message block 1.0 server. We've got a real opportunity here because our own Lou Maresca, well, he knows more than a little bit about this. Lou, can you give us just a little bit of a picture as to what SMB v1 does in the context of Windows?
Absolutely. So yeah, like Curt said, SMB is what they call service message block, and it's a network file sharing protocol that they developed way back in Windows 2000 that essentially uses different layers of your network layer. It either uses the NetBIOS transport or TCP/IP, and allows you to kind of connect between another machine to basically share data. And most of the time, this particular protocol, obviously, I think it's on version 3.0 right now. And in fact, multiple versions of Windows support the different versions of the protocol. So, for instance, Windows 10 you can actually enable the version 1 version of the protocol itself. But in general, it's got multiple layers of security. It's got what they call user level and share level security. And both of them are actually the passwords that go between them are actually encrypted, it's basically a challenge or response type of authentication method. But again, this all depends on the version of the protocol, how this is handled. So the version 1 obviously has this particular exploit in it, and now they're exploiting it if people have it enabled on their OS. By default, in some of the operating systems, it's enabled. Most you can actually shut it down. So it's actually interesting that they found this exploit on some of the latest OSs.
Yeah, we do know, going through some of the charts that various CERT groups have put up, that it does affect all the way up through the latest versions of Windows 10. And I have read in a number of places that it's actually on by default as recently as some versions of Windows 10. To me, the amazing thing, though, is that Microsoft was very proactive in patching this vulnerability. The patch for this was actually released to the public a couple of weeks ahead of that shadow broker's NSA data dump. So any company or any individual that is in the practice of updating their systems, especially on one that is designated a critical system vulnerability, as this one was, shouldn't have a real problem. It's also important to note that this is not the actual ransomware. What we're talking about in terms of this vulnerability is the transport and infection method for the ransomware. The ransomware is a variant of something that we've seen a number of times before. The difference in this particular infection is that we have this amazingly effective transport mechanism that, as it turns out, was developed by our own government. What we don't know, as far as I'm aware, is how long this vulnerability existed before it was patched. In other words, was the vulnerability in SMB1 something that has been there since the very first iteration, or was it something that was inadvertently introduced in a much later series of upgrades? I'm not aware of anyone who thus far has been able to tell us that. Lou, you were involved in a lot of application development, and this whole thing with the non-patching, leads to something that I don't know whether you've got some insight on, but I'd be interested in your take. And that is the notion of depending upon customers to actually apply updates. Do you have any kind of rule of thumb? I mean, obviously, there's no update that you can depend on being applied to 100% of the systems out there, whether we're talking about operating system or application. But do you find that the majority of users, at least, are applying updates these days?
Yeah, I think that's a really good question. And the answer to that, to me, in my particular scenario, is no. In fact, when you have these rich clients, these thick clients, and these applications being installed on these machines, kind of what we call the old legacy style of application deployment, where you have a machine has got an OS put on it, and you bring down these binary bits and actually install them as executables on the machine, is kind of the old style. Now, obviously, the cloud services and the SOA service-oriented architectures are kind of out there. And people are using web apps and more lightweight type things that don't necessarily require binaries installing on your machine. So a lot of the old legacy styles, need to be patched sometimes. If there's vulnerabilities found, they require somebody to go and run an update on their service or their application in order to get those updates. And even if you put automatic updates on things, including on your cell phone, these things are binaries installed on your cell phone. If you don't have automatic updates enabled, or you don't go check the store for when an application is updated or when the OS is updated, if you don't actually do that, you're not going to get the updates, which means that includes your security patches. And that creates vulnerabilities and holes in the system. And, you'll start to see these kind of like bell curve graphs that show the distribution of how many people actually get the update. And only systems that kind of force the update, like some of the new operating systems, like iOS operating system as well as Windows 10, are starting to force updates, especially around security vulnerabilities, to come down to the system. Now, again, enterprises can still block that if they want to, if they make that decision. Which is not always the best decision, but sometimes they want to regulate what kind of bits that kind of come over the wire and how they affect those systems. And they're not as containerized as they would hope. So I think, and again, applications sometimes depend on functionality that might be changed by some of the updates. So I think, it's a slippery slope because you don't know when or how you want to take these updates. But when you have something like this, that could be it can basically spread like wildfire throughout the system, and that they had a patch right away, and you're not getting that patch because you have turned off all these functionality. That's just negligence on the people who own the systems, unfortunately. Now, is it always negligence on the people who own the system? No. Sometimes it should be. To me, it's up to the platform to sometimes make decisions. Especially if it can cause some data damaging and privacy issues, security issues. But again, each company does it differently. As well as Mac and OS X and from Apple also does it a little differently as well. So, it's all dependent on the company and how it's implemented from that delivery method.
I have to jump in because I have rallied against Microsoft. I have been caught by a unwanted update more than once. In fact, a couple of times on live shows, which is annoying. But more annoying is when it would do things like set off an update in the middle of a render. I had a 16-hour render. At 5 hours in, Microsoft just decided, even though it was active hours, no, you're going to update now. But I get it, and we've talked a little bit about this. The balance between letting users do what they want to do, because that's why I have a PC. That's why I love my PC. I can do what I want to do, and making sure that they're just protected against themselves. Some people, if we're given the chance, would never update their systems, and this absolutely would bite, especially if their personal security habits aren't so great. Curtis, I'm a little afraid of this because we're going to see more of this. There's a lot of toolkits out in the wild with some very sophisticated tools. There are a lot of unpatched systems all across the world. And it would seem that we're ripe now. We are in the data, the cyber, the electronic attack era. And aside from the fact that the scope of this was just so large, I think it demonstrates how so many of our critical systems can be affected by something like a ransomware attack. Is this the first salvo, or is this the latest salvo in continuing?
I think it's the latest salvo, but I do think that it is a salvo that marks a new chapter in this malware. It's a couple of things that make it so. One is that it is the use by a criminal organization, because no one has suggested that this is anything but that, of a tool developed by a nation state. So here we have a tool developed by a nation state, which means it was developed by an organization with, let's call it, unlimited resources, released into the wild, and now exploited by a criminal enterprise. I think we can count on seeing more of that. Another thing that is worth mentioning, we've talked about this very sophisticated attack vector that was developed by NSA, but we have to realize that the initial attack vector, the way this was introduced into these systems, was when users clicked on an attachment to a spam email. That attachment was a zip file. Once it was opened, it went out, infected the system, and started spreading like wildfire. So the day zero, if you will, about all of this is training users. We still haven't convinced users that it's a bad idea to click on attachments that come in via email from people they don't know. Once we get that through people's heads, it will be a lot easier. Now, this story is continuing to break, continuing to develop. I'm going to recommend that this is an opportunity to really use Twitter for what it's great for, which is gathering the information. If you go to Twitter and you search on the name of the malware, which is WannaCry, WANNACRY, and malware, you'll get a stream that is just updating like mad as more and more reports come in from around the world. I'm going to be keeping an eye on it. Follow me at KG4GWA, and also I've got that story at Light Reading that I will be updating through the weekend.
Yeah, and let's just say to our audience that right now, if you're not infected, do yourself a favor and update. Update everything that you possibly can, especially if you've been holding back for a while. Because remember, Microsoft did patch this more than a month ago, and if you've been holding off since then, you actually are vulnerable. We're going to have to move on. But before we go, one last little bit I want to throw out to our audience is, and Curtis touched on this, let me do this in my most stately voice. Stop clicking. Are we happy? All right, let's move on. Lou, let's move to some happy news. We've been talking about some depressing stuff, but there's been some interesting things going on your campus. I was originally supposed to be there, but then I got called away to a super secret something other. But I'd like to hear from someone who's actually there. What's going on the other side of campus?
Sure, yeah. So, of course, I'm probably already heard Microsoft Build 2017 is going on. And the Build conference is kind of like a multi-day event where they kind of bring together people and organizations in the enterprise to kind of show them how to be more productive, some of the new innovations they're kind of putting out to kind of remove any of the impedance that you might have around some of the workflows and processes that you have in your org, especially from around software development to deployment to security, all these types of things. And sometimes the content, there's so much content, it's kind of a whirlwind, and it's a little bit of overwhelming sometimes. So we wanted to kind of go over maybe some of the highlights and some of the items that they brought out. And one of the things I really like about Build is the fact that you can go there and not only can you learn about these things, but you can talk to the experts, the engineers that are actually developing these things. I always find it really valuable, especially as an engineer, to go talk to customers and partners and enterprise people, IT admins, about how they're using it and what kind of issues they have and how they can get over these issues and how some of the new technology can apply. But for this particular event, again, there's 3 days, so we would need an entire episode, I think, to kind of go over everything here. But I picked some highlights out. Starting on day one, they debuted what they call Cosmos DB. And this is very interesting because this is basically a rebranding of what they used to call Document DB. And it's essentially what they're calling the industry's first globally distributed and multi-model database service. And what that means is Cosmos DB was built from the ground up in order to allow for not only horizontal and global distribution, but also horizontal scale. It essentially gives you the ability for what they call turnkey georeplication and distribution across any region in the world, and it gives you a little bit more transparency around its scale and distribution of data. And so if you're not familiar with Document DB, essentially it was a document, it's an API for a document data storage It stores your documents. It indexed all the data, all the attributes on that document. Allowed you to search and do queries and create an update. And it offered some reliability and availability of that data across some nodes. Now, what Cosmo DBs is, it not only umbrellas that, it adds additional functionality. It guarantees what they call 4-dimensional SLA, which means not only do they guarantee availability, reliability, but also consistency and performance. And so if you're familiar with database consistency models today, most of the time they only handle 2 models, and which is, if you're familiar with strong consistency, where everything's like transactional, and then what they call eventual, which eventually your data will be updated at some point. But Cosmos actually offers 3 intermediary levels of consistency, and they offer what they call there is prefix, which is right in the middle, right smack in the middle. There's also one that they call the prefix one's actually pretty interesting, but again, there's also 2 other levels of them, and they offer the ability to a session-based consistency, which they call the prefix, as well as the bound staleness one, which is really kind of closer to the transactional one, and it'll let you kind of guarantee consistency at a particular SLA. So you might say, hey, my data needs to be consistent by this particular amount of time, and so they can actually guarantee that consistency. So it allows you kind of, again, what they call turnkey, but allows you to essentially dial up and dial down depending on whether you want more consistency or more performance, that kind of thing. So that's kind of where Cosmos DB is coming from. So it's a kind of a massive a debut of this database, and a lot of new systems today are actually using Cosmos DB under the covers to actually handle the scales, things like Skype and so on.
I love that. I love that choosable consistency model. I mean, I think that's something that's been missing for a while. The ability to say, hey, you know what? If I want more consistency, I can pay for it. And if it's not something that needs absolute consistency across the board on every experience, then I'll say, okay, that gets a lesser agreement. That's been missing for a while. So yeah, kudos on Microsoft for ferreting that out.
Right. So I think that was one thing. Obviously, moving on, there's a lot more to cover. So there's also they debuted PostgreSQL and MySQL as a service. And this is not just, hey, let's go spin up a VM and then install Postgres and then spin up a bunch of other nodes and replicate them. Essentially what this is you just contact it as an API, you use it as an API, and they do all the work under the covers to host it and handle it and scale it out. And so that's both for Postgres and MySQL. So this will be huge for people who have been waiting for that, have been paying for their infrastructure in clouds like Azure and AWS and other places to host this out. Now they can do it as a service. They don't have to maintain and handle all the administration of that, as well as the scale and reliability of it. They just basically use it as an API. So that's huge. Not only that, the Microsoft Graph is another big thing. So previously they debuted it as the Office Graph, Office 365 unified platform or unified application programming interface was what I think it was called. But essentially now the Microsoft Graph was what they call GA, general availability. And what it does is it adds things like AD integration, Active Directory, Outlook, Mail, Calendar, Planner, OneDrive, Excel, OneNote, as well as SharePoint integration. But it also brings a preview to many APIs like Microsoft Teams and the Insights, Outlook Tasks, Intune, Office 365 reporting, and also a new really cool project called Project Roam, which essentially connects apps across devices. And in fact, there's another thing that came out that actually is built on top of that. We'll talk about that in a second. Of course, there's also a ton of announcements around Azure. There's something called Azure Cloud Shell, which essentially is a bash shell right in your browser, right on the dashboard for Azure, which is really kind of a cool thing for you to do. You can maintain all your resources and VMs and so on just using a bash shell within the browser. There's Azure IoT Edge, which essentially allows you to package up all of your software for IoT and allow you to kind of distribute and deploy devices that are not always connected to the internet. And it allows you to build in like advanced analytics and machine learning and AI in the cloud, as well as onto physical devices using IoT Edge without having necessarily, like I said, having to be connected all the time. And one thing that I'm really excited about is, as a developer, is it's just a simple thing actually, but it's called Azure Snapshot Debugging. And this is super cool because you can actually debug a live production site or application that's hosted in Azure right from Visual Studio, and it doesn't actually impact production anyway. And what they do is allow you to essentially take these small little snapshots instead of breakpoints. They call it snap points, and you use the basically little dumps or traces in the background, and then you can load that up in Visual Studio, and you can essentially step through your code as if you were in real time, and you can run commands and look at the data inside the memory and so on and so forth. And it doesn't allow you to hack. It doesn't actually impact production, so really kind of cool. Also, Visual Studio for Mac was GA'd, which is kind of cool. It's basically a superset of Xamarin Studio. And of course, Service Fabric. I know there's a bunch of announcements around that. And again, Cosmos DBs is actually built on top of Service Fabric, because Service Fabric is a programming, it's basically a service that provides stateless and stateful microservices capabilities. And it allows you to kind of fastly deploy and monitor, and has high availability, and it does distributed building blocks for you. So that's why a lot of these services are built on top of it. It now supports containers, which is huge. Yeah, exactly. A couple more things here. Of course, they also added a cognitive services API, additional APIs, 29 more, which is around speech and language and image processing. So they added a bunch of things there. And in fact, some of the new Windows Redstone 3, which is now officially called Windows 10 Fall Creators Update, and that was debuted.
This is the one that's going to affect everyone. So the other parts are things that will affect developers and admins and people who are doing deployments, but everyone's going to be using Windows 10. Tell me a little bit about the Fall Creators Update. We've been hearing little bits and pieces across the Twit network of what's this going to include, but what are the bullet points?
So one of the biggest ones, I think, is that they're trying to change the way application is developed, and think of it more of an experience. So what they're trying to do is they're trying to bring in what they call the fluent design system around application development. And what that means is they want you to think more around, how you can adapt your application to the different devices that it's on, and add more things like light and depth and motion and material, like feeling and scale to your applications. And they debuted a bunch of ways of doing that. It's kind of built into the platform moving forward. And instead of just thinking about a flat interface, it's similar to if you think about Google's material design. It's very flat. And so what they're doing is they're saying this is the next generation. This allows you to adapt your interfaces to, augmented and virtual reality devices, and allows you to really add depth and perception, and allows you to games to be more interactive and fluid. And so that's kind of where they're moving to. So they debuted a whole bunch of that. But they also showed a bunch of capabilities that were built on top of some of the other services as well that will debut inside of the Windows version as well. So an example is, well, I kind of threw my hands up and said it's about time, is the cloud-powered clipboard. And this is kind of a cool thing. It's actually built on top of Project Rome, and allows you to have clipboard access across all your devices. So for instance, if I copied something from my, on my iOS device, and I said, hey, I want to go and, paste this into a document, you copy it, you use your Swift keyboard, and you say copy, and then in your Word on your PC, you just go to the clipboard and paste, and boom, it just pastes across the device. No, there's no blocking you from doing that, and you can kind of go to any device and do that. And it'll work on Android, iOS, Windows Phone, Windows, and Mac OS. So I think that they're kind of moving across the boundaries and trying to find a way to make you more productive without worrying about what platform you're on. And then the other thing is a bunch of people cheered, especially my family, which is around Story Remix 3D. And what this is essentially like the revival, I call it, of Movie Maker. So a lot of people were ticked off about Movie Maker disappearing from Windows 10. But this adds a ton of things like special effects capabilities, green screen capabilities, but it also adds AI and deep learning capabilities within it as well. And then, of course, finally, the Windows Store. Windows Store is getting a huge overhaul because of Windows 10S. Windows 10S doesn't allow you to run executables on the device. It only allows you to install and run Windows Store applications. So there was a huge, massive amount of announcements around that. One of the biggest ones is everyone cheered about iTunes being in the Windows Store. So that's actually coming. And then, of course, couple shocking things was around different distributions of Linux, like Fedora and SUSE and Ubuntu are all coming to the store. So they like to say bash galore, because you get to use all these different operating systems running right on your Windows S device, which is kind of interesting. So again, lots of stuff going on, and there's a ton more that I didn't even get to, but some really interesting kind of coming things out of Microsoft this week.
We're gonna cover that more in depth. Unfortunately, we have to move on just because we're running out of time. But seriously, there was a lot of stuff coming out of Build this year. We're going to be covering a lot of the Windows 10 updates on Know-How because there are a few of those features that aren't just throw-ins. They're not just value adds. They're actually pretty good. I'm glad that you brought up a remix because I have had people ask me if there's something kind of like Windows Movie Maker that was easy to use and put out some decent quality videos. Well, we've got it again, but we got to teach you how to do it. So, Lou, thank you very much, and thank you for being on the Microsoft campus because it allows you to peek out over the windows and see what's going on. Now, gentlemen, we've got something special for you. If you've ever wanted to see how exactly fast you could get on your current generation of PCs with storage, we've got it. We've got Kingston in the house with one of their test systems who are going to show us a little something about this. You're probably going to see this very much in the near future. This is their new DCP 1000. You're going to see exactly why you should be excited. But first, let's go ahead and take a moment to thank another sponsor of This Week in Enterprise Tech. Now, this episode is brought to you by GoCD. It's the on-premise open-source continuous delivery server created by ThoughtWorks that is the easiest way to model complex workflows across multiple teams with ease. Now, GoCD understands the difficulty of deployment in a 24/7 environment that demands the 5 nines of uptimes even as real-time deployment is expected. That's why they've built their delivery system to give you comprehensive pipeline modeling, easily configured dependencies for fast feedback, and on-demand deployment with parallel and sequential execution. Of course, if you've ever worked in deployment, you know that it's not just about what your tool does, but it's also what your tool doesn't do. Specifically, GoCD doesn't burden you with spurious builds. It gives you fan-in, fan-out dependency management, so you're never wasting time with an unneeded build. Their value stream map lets you track a change from commit to deploy at a glance, and the real power is in the visibility that it gives you over your end-to-end workflow. So you get complete control of and visibility into all of your deployments across the organization. GoCD also offers complete customization for your software's individual needs so you can tailor it to work the way you want it to work. GoCD will perform tests written in most languages or frameworks. And, this is important, their test reporting is so thorough that it won't just tell you that your build broke, that it failed a test, which is what a lot of other tools will do. No, with GoCD, you get complete visibility into which chain set on which platform a test started breaking. That just helps you develop more efficiently. You can compare content across any 2 arbitrary builds, making it invaluable when troubleshooting a broken pipeline. And GoCD is fantastically flexible. It supports audible deployment. It lets you delegate the configuration of pipelines to users without full-blown admin privileges, so you don't have to do everything, and you don't have to grant someone admin privileges when they really shouldn't have them. It has extension points that let you connect any of a number of ready plugins or plugins that you can write yourself. The TLDR is this. You can say goodbye to deployment panic and hello to consistent, predictable deliveries. GoCD is an open source project that you can download and use for free. Discover the power of their pipelines at gocd.io/twit. That's gocd.io/twit. Commercial support and enterprise add-ons, including disaster recovery, are also available, and we thank GoCD for their support of This Week in Enterprise Tech. We welcome back to the show a man who, I just love it anytime he can be in the studio because he is a font of knowledge about all things storage. Mr. Cameron Crandall. Cameron, thank you very much for coming back onto This Week in Enterprise Tech.
Thank you.
Now, you're here because this is here. This is the Kingston DCP 1000. Now, we got a sneak peek at this last year. We saw a bit more at CES, but now this is actually ready for the marketplace. If someone were to go up to you and say, well, what is a DCP 1000, what would you tell them?
In its basic form, it's a high-performance NVMe SSD. So NVMe is the new storage protocol for attaching SSDs to the PCI Express bus.
Right, right. And, of course, we've had storage options aplenty over the last couple of years, especially with the advent of M.2 devices that are really kind of stretching the boundaries of what you can get over a couple of lanes of PCIe revision 2 and revision 3. But the DCP 1000 is special because where on a high-performance part, a modern high-performance part, I might be able to manage, say, 2,500 megabytes per second, maybe 100, 150,000 IOPS per second. The DCP does more. Tell me about the performance.
Yeah, so M.2 is good for kind of smaller implementations, desktop systems. Some of our server boards are using them for boot. The DCP 1000 is really designed for really a high performance data drive in a server. So really we see databases being run off of this. Very, very high performance workloads. So this drive is actually capable of delivering 7,000 megabytes a second of throughput and over 1 million read IOPS off of a single card.
Okay. Again, let's back up, put that in perspective. So a typical high performance drive that I might end up with in my consumer PC, if I was willing to pay for it, would be 2,500 megabits per second. This does 7,000. I'd be expecting 100 to 150,000 IOPS. This does over 1 million.
Yeah.
All right. So a little bit of a performance jump, which I got to ask, how did you do that? Because, I mean, when everyone else is topping out at about 200 to 2,500 megabytes per second and 100 to 150,000 IOPS, how do you increase that by an order of magnitude?
So we do it through aggregation. So today we've got the availability of PCI Express switching technology. So what we do, instead of laying down a big 32-channel controller on this card with a lot of NAND, we actually aggregate 4 physical controllers behind a switch and bring that to the PCI Express bus, and that's what enables us to get those giant performance numbers.
Okay, all right. I'm going to have to stop here because you say switch. I know there's going to be people in my audience who their ears kind of perk up and they say, okay, if you're adding something that's switching between controllers, I'm going to add a lot of latency, right? I mean, it's just going to kill it because now I don't have full-time access to all 4 of those controllers. I only have it when the switch is pointing to that controller. Does this kill latency?
It doesn't kill it. I mean, there's a small penalty, right? We're doing this in hardware, so the penalty is very, very small. In the NVMe deployments today and into the future, NVMe and PCI Express switching is really a necessity to be able to scale PCI Express because of the lane limitation of PCIe and the processors.
Yeah, and Kevin, if you could go ahead and take a look at the system. We actually have a camera pointed at right now. This right here. So this is not what you would expect out of a PCIe board. When we've seen these in the past, it's typically just an interface between an M.2 slot and the PCIe. This is 4 M.2s, although that's not really that important, with what's doing the switching. So what piece of silicon is doing the switching between them?
So we have a PLX switch. It's an Avago switch that's used to do that switching. And again, the PCI Express switching technology is now mainstream and readily available. You see it a lot used on server backplanes for aggregating U.2 SSDs. We've brought that to the half height, half length card to aggregate controllers and NAND to get high performance to the single PCI Express slot. Basically, we're able to deliver flash array type performance to the PCI Express bus.
That's amazing. We have seen solutions that could do that in the past. Fusion IO is famous for having done something like this almost, more than a decade ago, maybe 15 years ago. But their solution was entirely proprietary and was ridiculously expensive. Obviously, the price goes way down when you start using off-the-shelf pieces. But what did Kingston have to do? Because I know there's some serious design work in here. What did Kingston have to do to be able to implement a switching technology between 4 M.2 products in order to get that kind of performance without getting the penalty that you would typically associate with switching?
So, a couple of things. Like you said, everything's off the shelf now, right? NVMe is mature. The PCI Express switching technology is mature and it's readily available at a low price point. One of the advantages we have, we control the firmware on the SSD as well as on the PCI Express switch. And within that, we're able to do sophisticated things which enable the performance we're talking about.
Right. This is a Revision 3 product. So what in Revision 3, how much throughput do I have on every lane of PCIe?
So you've got the capability of 1,000 megabytes a second per lane.
And this will do PCIe 3 revision 3 by 8.
By 8, yeah. And we're
Okay.
almost saturating that at nearly 7,000 megabytes a second.
And this is something that we've talked about last year when we had you in individual segments. How many lanes would I have on a typical, say, server motherboard?
So it depends on the processor. You could have anywhere from it really depends on the processor, up to 40, 45 lanes.
Yeah, but what would the typical loadout be? And let's pull back. Let's say a system that might be used on a desktop. I'd get access to how many?
You're probably looking at 25 to 35 lanes.
Right. And so between the graphics card and whatever else I might want in there, you really start to run out quickly.
Correct.
And was that one of the driving factors behind using switching technology on a single card?
It was. You will run through PCI Express lanes pretty quickly once you start adding SSDs that want to utilize lots and lots of channels, right? So yeah, definitely, it was the switch is there for primarily for aggregation of those physical devices to a single PCI Express slot. So basically, you don't have to go out and make a new investment in a system that supports NVMe bays.
Right.
You can drop this card in immediately and take advantage of the performance of NVMe and the scalability that comes by way of the switch.
Yeah. I'm going to have to ask, is SATA dead? I mean, obviously, it's still fast enough for what we do today, but it would seem that most of the new technologies coming out today from Kingston and other storage manufacturers, they can provide so much more than what you can get over the SATA bus. Even if you were to rev the SATA bus again, it's not really keeping up.
Yeah, SATA will always be a low-cost play. I mean, not only in the client space, but even in the data center. But definitely as NVMe begins to come down in cost, and not that it's that far away from SATA in terms of cost, NVMe will begin to put a lot of pressure on SATA, especially if it's at the same price point.
Right.
Then there's really no reason to stay with SATA, and you should go to the next bump in performance.
Yeah, it's going to be like every interface that's ever come across. You go from RLL, MFM, IDE. Eventually, you're going to see systems that still support them because those devices will still be out there, but they'll just start disappearing because the performance just isn't there.
Yeah, they'll coexist for a while, and then again, when the price point of NVMe comes down in the form of M.2s on client systems and U.2 on the server, it's pretty much a no-brainer at that point. You would move to PCIe.
All right. Now let's talk a little bit about the setup on the desk, because right now we've got this wonderful little box that's running one of the DCP 1000s. There's also a U.2 device in there. You're running iometer. Can you actually show us?
Sure.
What's going on? So tell me what's going on here.
So we've got two of our devices in the system. So we've got the DCP 1000, which is shipping today, that we're talking about, and then also our DCU 1000, which is our U.2 SSD. It's a prototype that's running. So basically, what we're showing here is iometer, which is a very common workload generator for SSDs. And we're showing that these two physical devices are producing 1.8 million read IOPS off of two physical devices. And to get this type of performance with SATA SSDs, we'd have to use 3 RAID controllers, 24 drives. Now we're able to deliver this type of performance to the PCI Express socket.
Oh, because I remember Kingston a while back having one of those Uber systems set up with, I don't know how many drives were in it, but it was in a transparent case, and it was getting ridiculous throughput. But you're right, I had to basically fill the case with drives. You are allowing me to do that on a single board.
Yep.
Which is different. Okay. The other unit is in there, and we do need to talk about that, is that U.2 device. Tell me about the U.2 interface.
So U.2 is necessary from a serviceability standpoint, right? What I like to call the traditional storage model, which we're all familiar with, we're all comfortable with. We need to be able to hot plug SSDs in the data center, right? So if we want to go out and displace racks and racks of SATA and SAS-based hard drives and SSDs, we have to make PCI Express serviceable. So U.2 is necessary for that serviceability aspect and scalability. I would add that as well. But the serviceability is key. People are not going to abandon HA and serviceability practices. So we have to have U.2 in order to achieve that.
Right, and it just makes sense because yes, it's nice having something that's really fast on a single card, but if I've got dozens upon hundreds of systems, you want something that's front of rack rather than having to pull the entire chassis out.
Correct.
Okay. Let's talk about something that we've seen over the last couple of years. There's been this weird reversal because we got so accustomed to technology starting in the enterprise and then trickling down to the consumer. Over the last decade, that kind of reversed. You started seeing some high-performance technologies start in the consumer area and then move in the enterprise. The most noticeable was Flash, where it really started in consumer, and then you started getting companies that were recognizing they would love higher IOPS and higher throughput inside of a box. But that kind of, well, it doesn't always work so well when you take a consumer drive and stuff it into an enterprise box. Why is that?
So several years ago, we were able to give a data center customer a high-performance client-based drive, and they loved it. It was so much faster than the hard drive that it was wonderful. Now what we're seeing is the data center customer is more competent. They understand the SSD technology more, and now they're peeling back the onion a little bit further. What's good for a desktop application not always is good for a server-based application. And primarily what those folks like to look at is performance consistency.
Right.
How consistent is the IOPS performance that's being delivered from the SSD? They weren't necessarily looking at that on the client drives as much as they are now. And latency. Does the drive go away for a long period of time, and does it respond slowly? So these customers have written their own testing applications for SSDs, and they put us to the test. They'll line up a Kingston drive and 2 or 3 of our competitors, and they'll look for weaknesses in the design, and they'll call us out on it if they see it. So latency and IOPS performance consistency are really the key in the data center, and the data center customer is much more sophisticated today than they've ever been.
Yeah, it's starting to become common to say that bandwidth numbers are great for bragging rights, but when you're actually talking about real-time workload, if you don't have low latency, if you don't have the IOPS, you could have as fast of a drive as possible, but you could do one thing very fast, not everything that you would need on a typical modern OS.
Right.
Okay. Oh, we've had Alan Malventano come on. And he's been developing a new way to test fast storage subsystems. And he's always been impressed with how well Kingston has done. And that's one of the things that he's really noticed about your drives, which is when you start hammering some of the high bandwidth parts, their latency goes way up and their IOPS go way down. Kingston's always sort of stayed the path. How is that different? I mean, this is still a little bit magic to some of our audience where they think, well, Flash is Flash. A controller is a controller. A part is a part. How is it that one device that looks identical to another device might be able to survive an enterprise workload versus a consumer workload, whereas another just dies, just fails?
Yeah, so a lot of that has to do with firmware design for the SSD, and like anything, you've got to give up something somewhere to get an improvement somewhere else, right? So if our goal is performance consistency, maybe we take a little bit of hit in the bandwidth performance. So maybe we're not doing 550 megabytes a second. Maybe we're doing 500 or 480 megabytes a second. But what we get from that is performance consistency.
Right.
So firmware is key. Being able to hold a large part of the drive's mapping table in a DRAM cache is a big part of that as well, as opposed to it being in Flash. So there's a lot of considerations how your garbage collection, your background operations are done, when they're done, how they're done, all affects that performance consistency. And so now in today's SSD market, we really have SSDs that are really application specific, and it's great for the customer because they can buy a low cost SSD that's designed for client use, or maybe they want to do read only type of application work, and then you've got the complete other spectrum where you've got drives that are better for random write performance.
Right.
So there's a good variety of SSDs in the marketplace today to really address different types of workloads, but performance consistency and high IOPS performance for the data center is really the key for what most of our data center customers are looking for.
Looking at these products that we've got in front of us, so we've got the PCIe DCP-1000, and then we've got the U2 unit. What kind of capacities are we going to expect to see in those?
So both of these drives are offered in 800 gig, 1.6 terabyte, and 3.2 terabyte.
Right. Yeah. Our audience would notice if I didn't mention another technology that's very exciting right now, and that's Crosspoint, where we've finally seen an actual retail product from Intel for their new Crosspoint technology. And it's nice. It's very fast. We had Alan Malventano come on the other week, and he showed off the specs, and he said he was very impressed. It is a next-generation product, but one of the things about it was incredibly, fantastically expensive for not that much. I mean, you have 300 gigabytes, and I think it was a $1,600 drive.
Yeah.
But my question to you would be: is Crosspoint going to eliminate Flash? I mean, is that a natural progression, or do you see the two technologies coexisting?
I think I see them coexisting. Crosspoint definitely has a nice performance play. I really see it more in a tiering fashion. And again, if you look at SSDs, SSDs are really give you the ability to do more with less, right? So if you can put a performance tier in your storage solution, Crosspoint fits in there. But if you look at really the mass deployment of Flash in terms of U.2 and half height, half length cards, I think the real volume will still be in the form factors that we're all familiar with and accustomed to.
Right. And honestly, we're used to this sort of tiering of technologies. Yeah, it would be nice to have the fastest storage technology possible at the capacities that I want, but realistically, that's just not going to happen. You're always going to be having a hybrid of various technologies in order to get the best price performance.
Yep.
Yeah. All right. We've also got people in the chat room who are already making jokes about which bank they need to rob in order to buy one of these products. Crosspoint it's significant. You're talking $4 or $5 per gigabyte. What would a DCP-1000 run me?
So these today sit at about $1 per gigabyte.
Ooh,
so if we compare that to SATA today, everybody compares everything to SATA. SATA, a good high performance SATA SSD for the data center, runs about 45 cents a gig in today's flash market. So yeah, it is twice as expensive. But in the grand scheme of things, it's much faster. You can't always look at the kind of the dollar per gigabyte aspect of this type of a device, but I mean, in comparison to the PCIe products that dominated this marketplace over the last decade, like you talked about, it's very inexpensive.
Right. And what about the scalability? Because I love the switching approach. Back when you told me about it last year, I said, yes, this is how products are going to be designed into the future, because if I can get a switch that has almost no performance penalty, it allows me to layer different controllers behind that switch and essentially scale out infinitely.
Right.
How far can you push this technology before it starts pushing back?
Well, I think if you look at the DCP-1000, you could probably put 2, maybe 3 of these into a system, and then you've simply you've aggregated 8 or 12 physical devices to 3 PCI Express sockets. But server backplanes, in order to get 8, 16, or 24 U.2 SSDs into a server, the switching technology is a necessity. So where the actual breaking point, if once you've got once you're stacking switch chips upon switch chips,
then we have
at some point you might start to see a problem. But that switching technology, you will have drives that plug into the 2.5-inch bay that may have switching technology in it that attach to a switch on the backplane before it hits the processor. So to answer your question specifically, I don't know where that tipping point actually is.
We'll know it when we hit it.
Yeah, but again, the switching technology is a necessity to really scale NVMe storage. And if you look at the box builders today, they're using multiple switch schemes to address this. So.
We've also got a good question from Lone0001 who wants to know about the longevity. This is an enterprise product, so it's expected to last a lot longer. It's supposed to be able to handle a lot of thrashing versus a consumer model which might die after a couple of months in a data center. What kind of longevity should I expect out of a DCP 1000?
So this is a good question, and the endurance category for SSDs is quite wide. For Kingston, we've kind of chosen the larger endurance category market, which is 1 drive write per day. So we've honed in on this market, which makes up about 65% of the flash deployment, where the requirement is 1 or fewer drive writes per day. So it is a 1 drive write per day.
Yeah.
Yeah.
So in other words, yeah, this is way, 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 way more durable than anything I currently have in my enterprise loadout.
Sure.
Okay. One last question before we bring my co-host back in here, and that is, who's going to want this? I mean, of course, everyone wants it because it is bragging rights and it's bright and it's shiny and it's awesome. But in the enterprise, I see it used for transactional use. I mean, this is great for databases. It's perfect for databases, actually. But where else do you see something like a DCP 1000 being used? Of course, the U.2 project is aimed at data centers. But when I'm talking about this plugin, Rev 3 by 8 card, who is your market?
Our real market is the data center. Hyperscale environments will use this. Cloud service providers that have been using SSDs in large storage arrays. They want to shrink the footprint of their system and still have the same or better performance that they had before. I keep going back to this doing more with less thing because in the data center, the ability to do more with less results in a cost savings, and NVMe is going to enable that. So really, I think that's really the key market. We see some vertical markets. We talked earlier about the video editing community, the Hollywood studios that are now shooting in 4 and 8K, and the amount of data that's coming in to the storage now is incredible, and the ability to edit that data and manipulate that data in real time. You're going to need high bandwidth,
right?
And this type of a product, is key to that.
Yeah, I would just say this to our audience out there right now. I know you want one of these. I know you're salivating. We've already got people in the chat room who are talking about their dream build. This, however, this would kind of be wasted on you unless you are a video editor or do something else that requires a lot of IOPS. Yes, it's nice to have bragging rights, but this is probably not the product aimed for you.
Yeah, it would be overkill. It's for a gaming rig or a prosumer.
It would be faster.
It'd be fun, yeah. But yeah, the real advantage here is for the data center, and really what it enables in terms of transaction processing and doing more with less, like we talked about. That's really the market for this type of a device.
Let's go ahead and bring my co-host back in. I want to talk specifically to Curtis. Curtis. This is one of those pieces of tech that I've been waiting for a while. I mean, we got a sneak peek of it last year when it was still in its prototype stage. Easy sell for a database, right? I mean, if you are an IT manager talking to your CTO and you tell them, I can get you a part that is 10 times faster on IOPS, that is 4 times faster on raw bandwidth, that lasts longer, that runs cooler, that makes sense on our ROI, yes?
Oh, I think it does. And more critically, I think something like this makes sense on both of the major categories of database that you talk about in the enterprise, because traditionally you had 2 separate paths that you would take your storage hardware down. One is for the transactional side of things, where things like IOPS are critical. And frankly, this is where something like mainframes still hang on, just massive I/O engines. And a device like this will help deal with that. The other is OLAP, online analytics processing, which tends to be heavily read-oriented. OLTP, or online transaction processing, tends to be heavy write. OLAP tends to be heavy read. Devices like this, from what I'm hearing, the specs work for both, and that's the real breakthrough. When someone who's designing a system doesn't have to look at having two separate fleets of hardware and to estimate the needs for those types of hardware, I think that's an enormous win for anyone putting together systems in the enterprise.
And of course, I think it's absolutely important, and I think it was very wise for Kingston to release this, the DCP-1000, as well as the U.2 product, because it gives a system builder the two options. If you need something that just needs to be fast, it is the core of your transactional database, absolutely get the 3x8 product. But if this is going to be in the rack, it's going to be a workhorse server, the U.2 makes a whole lot more sense.
Yep.
Yeah. All right. I want to bring Lou in here. Lou, you work with a company that specializes in things like transactional databases. There is a feedback cycle that tends to happen between software and hardware, and that is when the hardware advances to a certain point and when you can start counting on certain minimum specs, you change how you develop. When a software developer knows that suddenly I've got a 10-fold increase on the number of IOPS that I can pull without destroying the hardware, that's going to change how they design. It's going to change how they make their software. How do you see something like this? If this were to become commonplace, when I could expect over 1 million IOPS out of every box, what does that do to someone designing the latest Microsoft CRM product or the Microsoft database products?
You know, it's interesting because these types of things have what they call a domino effect, because a lot of these new systems, like even these cloud DB systems, they offer, like I was talking about before, they offer different SLAs around consistency and performance and availability. And when you have, you know, something like this performing at the disk level, transactional level on particular machines or nodes in that array, you find out that, you know, that you reduce your latency to almost nothing, and that has a domino effect on the rest of them. You know, being able to be have higher performance would mean that your consistency can be a lot faster as well across globally, because you're not waiting on transactions to complete on these nodes. And so again, it has a domino effect, a cascading effect across the system. And when you're building systems that require, you know, that transactional capability, especially around databases, and especially around business software, where you want to make sure that you have this consistency with your data when you're making a change, when you're connecting from, you know, your client tier to your mid tier, then to your database tier. And so ensuring that performance, that raw performance is there, is a big thing, especially when you're querying large amounts of data. You know, a lot of systems, you know, for instance, nowadays cloud services, hey, say I have this email address, go and get me, you know, people that are similar to this email address, or go get me all the users that have this particular name, and you have to go rip through the system and try to find all of that. I mean, that type of query sometimes can be a graph query across multiple tables and joining all of these different things, and that sometimes hits the database and the disk pretty hard, and being able to reduce that amount of latency has a huge effect on the performance. So, you know, what I would say is, will it make it affect the way we design software? Probably. You know, what I could see in the industry is maybe people will be more negligent, I guess you could say, about this. And that's unfortunate. But, you know, some of the good engineers and software development organizations will pay attention, and they'll say, you know, we'll still pay attention to it. But in the same sense, we'll have to worry less about it. And I think that's the way to go going forward for sure.
I'm glad you brought that up, that it could introduce a little bit of laziness, because Java 78155 in the chat room nailed that right away, which is anytime you add this much headroom, suddenly optimizing your IOPS doesn't seem to be a problem. When you have so much excess, it's like, yeah, I could be lazy. I could not close off that thread. That's fine. But I'm okay with that, because eventually you get to the point where you're starting to hit that top again, and then you do re-optimize your code. Yeah. When Kingston looks at a product like this, when do you decide to release something? Because there is such a thing as releasing a product that is way too advanced for the market. That's just, you know, it's got a level of performance that we won't be using in the next 5 years. How do you decide when to release things?
Yeah, that's a good question. You know, I think this product, in a lot of ways, we do run up against that, right? And it's the higher end customer. It's the hyperscale type of customer. It is the cloud service provider that is on the leading edge of technology, where they can make use of this type of performance. I think the applications are available now. I think if you look at the mainstream market, a lot of people would say, you know, I don't know how I could use 1 million IOPS in my box. So for us, what we look at is the hyperscale community, which we already sell to. We look at the cloud service providers that we already sell to that are building next generation systems, and those are our focuses. And those companies are deploying NVMe today. Their systems are being built around NVMe, and they're paying the extra cost for the technology.
All right, we do have to close it up because we've gone way over time. This always happens whenever we get too excited about the tech. But I'm hoping you could give a cheat sheet to our IT workers in the audience. Of course, they're all going to naturally want this, but they're going to need to convince someone in management that this is something that they should play with. And hopefully it means that they can get a DCP 1000 or get the U.2 just to see how that might change how they build their systems, how they deploy. What would be the checklist that you want to give them? What are the things that they should look at so that they can actually go back to their CTO or their CFO and say, these are the areas in which we're going to see great ROI, or these are the areas which we most need this added performance?
Yeah, I'd go back to the doing more with less thing. I know I've said it repeatedly here on the show. I think, if companies are still on disk drive technology and they're using racks and racks of storage to serve a performance need, obviously moving to an NVMe type of SSD is going to help them out. Even if they're using racks of SATA or SAS-based SSDs, and they're starting to get up against a wall in terms of performance, or they're starting to be storage bound, I would look at reducing footprint size and what that costs. That'd be the first place I'd go in reducing the physical size of the system. By being able to deploy 1 or 2 NVMe SSDs to replace potentially a couple of racks of either hard drives or SSDs that are performing the same task.
Cameron, that's absolutely fantastic. Thank you again for coming all the way up here, for being with us on This Week in Enterprise Tech. I will say this is not the last you've seen of this technology. This very board, this DCP 1000, will be incorporated into a future know-how build. We're going to be doing a server build just to show how you could perhaps use one of these in your home. And of course, we're going to drop one into a gaming rig just for giggles, just to show you the numbers. Something else that Kingston did bring up, and unfortunately we didn't have enough time to play with, but big flash drives, and a while back, like a gigabyte or 500 gigabytes was a big flash drive. Kingston brought a 2 terabyte one. I don't know if you want to take a look at this, but we're probably going to shoot a segment for Know-How and TNSS. This is by far the largest and the fastest USB flash drive you will ever see. So, hey, it's Kingston. They do storage. This is what we are. Cameron, if you could, please tell the audience where they can find you, where they can find Kingston, where they can find out more information about the DCP 1000, about the U.2 product, where they could find more information about how Kingston is really sort of trying to give enterprise that sweet spot of price performance.
Yeah, our website's probably the best place to start, and that it would be kingston.com, and go to our SSD page, and there you're able to find our enterprise class SSDs, which will take you to the DCP 1000. And on that page, we have a lot of resources that talk about use cases, and a variety of other documents to kind of help describe what the drive is, how it's used, and you can see it up on the screen there. There's a lot of good information there about the drive and the technology.
Again, thank you, Cameron Crandall. We will welcome you back, hopefully with more cool things like the PC from the netherworld.
Thank you.
Gentlemen, unfortunately, you've done it again. You've used up another hour listening to the best dang enterprise podcast in the universe. That's according to 9 out of 10 SSDs who are really sad that they're not a DCP 1000. We want to thank everyone who makes this show possible. Of course, Cameron, but also my co-hosts. I could not do this show without them. We want to make sure we know what they're doing. Now, Lou, I know you can't say anything about it now, but you probably have an interesting announcement for the Twilight Ride in the future. Can you at least hint? Maybe?
Nope.
No hinting?
Nope.
No hinting. Okay, so we'll do the standard. Forget I just said that. Lou, where can we find you?
Well, you can always find me at Twitter at LouMM, and of course, all my work at Microsoft you can find at serum.dynamics.com, and check out some of the new announcements coming soon.
Can you at least smile at us so we know that there's something coming? Just give us that Lou Maresca smile. There we go. All right. Thank you, Lou. And of course, my good friend, Mr. Curtis Franklin from Light Reading. Curtis, you're always traveling. You're always covering events. What's on the schedule?
Well, next week I'm going to be in Austin, Texas at BCE 17. For those of you who aren't in the telecom world, that's Big Communications Event 2017. I'm leading some panels there and looking forward to eating some great barbecue. So that's what I'll be doing. I'll be reporting from there. So look for those pieces at Light Reading. Follow me on Twitter at KG4GWA. And by the time I get back, I'm going to have some even more exciting news for everyone in the Twiat audience.
Lou, Curtis, thank you so very much for another fun episode of This Week in Enterprise Tech. And of course, thanks to you, to the person who comes back every week to watch and to listen to the show. We wouldn't have a show if so many of you didn't come back always to support us, to find your dose of enterprise goodness. And we want to make it just a little bit easier for you to do that. If you go to our show page at twit.tv/Twiat, there you'll find not just all of our back episodes, not just the notes that are attached to each episode, but more importantly, you'll find a little drop-down menu where you can subscribe and have the version of your choice of our show delivered to your device of choice. Do you want the audio version in your iPhone so you can listen on the way to work? You can do that. Do you want a video version on your Android tablet so that you can watch us on your break? You can do that. Do you want the high-definition version in your Mac, your PC, your laptop, your desktop so you can watch us in HD goodness when you get home? You can do that. Again, just go to twit.tv/Twiat and be sure to subscribe. It's the best way to support the show and make sure that we can always bring you your Twiat goodness. Also, don't forget that you can follow me on Twitter at twitter.com/PadreSJ. If you follow me, you'll be able to find out what I'm doing each week. In fact, I just literally stepped off a jetliner from this place, Amsterdam. It was a 787, which I love. I would do a show on airplanes if I could talk about the 787 more. But yes, follow me on twitter.com/PadreSJ. Oh, and by the way, very interesting note. Did you know that in Amsterdam, Moana is known as Viana? I don't understand that. That's just weird. Also, don't forget to thank everyone in the studio who makes this show possible. That includes Kara and Alex, our engineer. It includes our fantastic Mr. Kevin TD guy. Kevin, do you have a mic on? Could you tell the audience what it is that you do every week?
Well, I forget how to TD when I'm not TDing for 1 week. You know, I wasn't TDing last week, so just jogging my memory this time.
Yeah, Kevin's a good guy. And of course, at the end of every show, we give Kevin an opportunity for redemption. Now, Kevin, we ask you something from the show to see if you were paying attention while you were pushing all of our buttons. And here's a super simple one. Just breathe it in, breathe it out. What revision and how many PCIe lanes do you need to properly run a DCP 1000?
NVMe revision and 1,822,790. I mean, 89, 92, 79. Yeah.
That was really close, Kevin.
IOPS.
That was really, really close. The answer, of course, was revision 3 and 8 lanes, but close.
Whatever.
Maybe you'll get it next week. Until next time, I'm Father Robert Ballister, the Digital Jesuit, just reminding you that if you want to know what's going on in the enterprise, just keep quiet.